All right, let's talk about something that's totally critical to how the cloud works, but is almost completely invisible to us as users. How cloud providers manage their gigantic resources to be both incredibly powerful and, well, efficient.
So, here's our game plan. We're going to start by pulling back the curtain on the real costs of cloud infrastructure. Then we'll get into the whole push for green computing. After that, we'll break down the two main ways providers save energy. First at the software level, then with hardware, before we wrap it all up with the ultimate balancing act they have to perform.
Okay, so to really get why resource management is such a huge deal, we first need to step away from our perspective as users and look at the cloud from the other side.
For pretty much all of us, right, the cloud just feels endless. You need more power, you click a button. You need more storage, you just get it. It scales on demand.
But here's the reality check. For the companies actually running the cloud, think Amazon, Microsoft, Google, that illusion of infinite resources is built on a very real, very finite, and unbelievably power-hungry physical infrastructure. I mean, just think about it. The sheer amount of electricity needed to run these global data centers is one of their biggest, most complex challenges. Getting it right is absolutely crucial for them to stay profitable and, sustainable.
Now here's where it gets really interesting. Where's all that energy actually go? Well, it's not just about powering the computers themselves. There's a whole other massive piece to this puzzle.
And wow, check this out. It's almost a 50-50 split. The servers and networking gear, the compute part, use just over half the power. The other 45% goes to just keeping the place running, mostly air conditioning and cooling systems. That's insane.
So you can imagine, with that kind of massive energy footprint, the entire industry has been pushing hard for what we now call green cloud computing. And the mission here really has a few different parts. Yeah, it's about reducing energy use to lower costs and shrink their carbon footprint, but, and this is the tricky part, they have to do all of that without breaking the performance and reliability promises they make to customers in their contracts, which are called service level agreements, or SLAs.
So what you have to understand is that this isn't just some feel-good, let's be eco-friendly thing. It's a hardcore business and engineering challenge that's leading to some incredible innovations, like schedulers that can literally think about power usage and heat distribution.
All right, so how do they actually do it? Let's start with the first set of solutions, which all happen at the software layer. And the main weapon in their arsenal here is controlling virtual machines, or VMs.
Now, to get this, you have to wrap your head around one really important, kind of counterintuitive concept: nonlinear power usage. It's a fancy term for a simple idea. A server's power draw doesn't scale nicely with how busy it is.
Take a look at this example. A server that's completely idle, doing nothing, is still pulling a ton of power. And a server running at 100% capacity, well, it's using more, but not that much more. And that's why this whole idea of VM consolidation is such a game changer. It is way, way more efficient to cram all your work onto one server and run it at full blast, while shutting 3 others down completely, than it is to have all 4 servers chugging along at a low load.
And the cool part is, the cloud platforms do this all the time, completely automatically. When demand drops, they perform what's called a live migration, which is just magically moving a running VM from one physical server to another with zero downtime. They pack the VMs tightly together, and then they can just power down entire racks of servers that are no longer needed. It's a huge power saver.
But wait, there's another slick software trick they use: optimizing the VM images themselves. Think of it like this. A standard VM image is often full of junk you don't need. By stripping all that out, you get a much smaller, leaner image that boots up faster, moves around faster, and uses less energy. Okay, so that's the software side of things. But clever code is only half the equation. You also have to get smart about the physical data center itself. Remember how we said cooling was a massive energy hog? Well, this is where they tackle that head on. We're talking about brilliant innovations in how they manage airflow, how they design the server racks themselves, and even how they deliver power more efficiently. All of this is just as important as the code.
And to all of this, well, it brings us to the central conflict, the real tightrope walk at the heart of cloud resource management.
You have to ask, right? Is just saving the most energy possible always the right move? Because if you get too aggressive with packing all those VMs onto fewer servers to save power, you could run into big trouble if demand suddenly spikes.
And the answer is, of course, no. The real art here isn't just minimizing energy use. It's about finding that perfect sweet spot, That perfect balance between performance, cost, and efficiency, so you can meet those customer promises, those SLAs, without wasting a single watt.
So, let's tie this all together. If you're studying for an exam or just want the main takeaways, these are the core ideas you really need to remember about modern cloud resource management.
And that really leaves us with one final big question to chew on. Our digital world is only getting bigger and hungrier for data and power. The race between that ever-growing appetite and our ability to power it all sustainably, well, that's one of the defining tech challenges of our time.